Hi everyone. In the first part of this tutorial, we connected React Flow with Yjs, enabling real-time collaboration. However, we still have two major issues. First, when the server restarts, all our work is lost. Second, collaboration feels blind because we can't see what others are doing. In this part, we will fix this. We'll add a database for persistence and implement the awareness mechanism to track user cursors. Let's start with the backend. Our goal is to save the diagram state to the database. In this tutorial, we are using SQLite for its simplicity, but you can use any database like Postgres or MySQL depending on your needs. The logic remains the same. Important note, we will save Yjs documents as binary BLOB objects without converting them to JSON. This is the most efficient approach and preserves the full merge history. In the server file, we initialize the database and create a documents table with a data column of type BLOB. The key components here are two HocusPocus hooks. onLoadDocument triggers when someone enters a room. We fetch the data from the DB and apply it to the in-memory document using y.applyUpdate. Conversely, onStoreDocument triggers automatically when changes are detected. Here, we pack the document state into a buffer using encode-state Yjs update and perform an upsert operation in the database, meaning we update the existing entry or create a new one if it doesn't exist. Let's test this in practice. I am currently the only user in the test room. Normally, without persistence, when the page is reloaded, the diagram state would be lost at this point. I'm refreshing the page, and I get exactly the same state I had before reloading. This means the state was correctly saved to the database and retrieved. Moving to the front end, we will focus on awareness. In Yjs, awareness is a mechanism for sharing ephemeral information, data that doesn't need to be saved in the document history, like user presence or activity. We will use this to implement real-time user cursors. But first, a quick look at the project structure change. I extracted the connection logic into a useHocuspocusProvider hook. Inside, I parse the document name and username from the URL parameters. This allows us to dynamically create rooms and simulate different users just by changing the URL. This hook returns the provider instance. This is crucial because this specific object gives us access to the Awareness API, which we need for the cursors. In app.tsx, we get the provider from our hook. To broadcast our presence, I created the update awareness function. It takes the mouse event and calls provider.setAwareness field. We pass our user metadata here, like the username and cursor position. This function is then attached to onMouseMove and onNodeDrag. To see other users, we use a use effect that subscribes to the update event on the awareness object. Inside this listener, we get a list of all states. We iterate through them, but we must filter out our own client ID, otherwise we would see a ghost cursor following us with a network delay. The remaining states are mapped to our local React state, which we then render as cursor components. There is a specific trap when implementing cursors in an infinite canvas like React Flow. Because users can zoom and pan, we cannot simply send raw screen pixels. If I did that, my cursor would appear in the wrong place for someone who has panned their view. Therefore, when sending data in Update Awareness, I use the Screen-to-Flow Position helper. This translates my screen pixels into the absolute coordinates of the diagram world. Conversely, when receiving someone else's position, I use Flow to Screen Position. This takes their absolute world coordinates and projects them onto my current screen viewport. This ensures the cursor sticks to the correct node, regardless of my zoom level. Let's see the final result. I have two windows open, one for Kate, one for Tom. As I move the mouse in Kate's window, you immediately see her labeled cursor moving in real time in Tom's view, and vice versa. It's fully interactive. Notice that even if these users have completely different zoom levels set up, the cursors still point exactly to the right spots on the diagram. They stick to the correct nodes, not just a position on the screen thanks to the coordinate transformations we implemented. So, we now have a complete system. Persistent data in the database and interactive cursors powered by awareness. This concludes the second part of our tutorial series on building collaborative applications with React Flow and Yjs. If you want to dive deeper or grab the source code we wrote today, check out the links in the video description below. You will find the GitHub repository there, as well as a link to our ebook if you are interested in mastering these technologies further. Thank you for watching, and see you next time.